Okay. Mhm. Okay. As I was saying, now our interest is to now compute or calculate the market equilibrium. And we are saying the market equilibrium, it means we have two conditions and the market equilibrium, where the first condition is about the quantity demand for and the quantity and the supply of the product, which must be balanced. Looking at the condition down there, it shows that QD is equals to QS. It means that there's a balance between supply and demand, looking at market equilibrium for the demand side. From the demand side. And we also have the same condition that applies in terms of price equilibrium, looking at the price equilibrium, where we say the price that consumers are willing to pay, it must be equals to, or it must be balanced with the price that the producer is willing to accept. So we're going to take an example. Like I said, if you look at these two, they were derived from the beginning, where I spoke about the linear function of demand and the linear function of supply. So you'll see there's no difference between what we have done previously. But now the idea is to prove this condition that we're saying QD is equals to subscript QS. So I will take an example just to demonstrate how are we calculating our, our equilibrium using the given information or using the given conditions. Okay. Where's my pen? We are saying under the condition QD is equals to QS. And we also have rather P, which is price, PD equals to P subscript S, which is supply. So remember, our objective is to calculate an equilibrium point. Let me just get the numbers. Can I quickly check something from my study guide? I don't have this information here. Okay. Okay. When I started, I said to you, to do this, we are still going to use the same equations, if you remember the linear equations that we started with when we were doing demand and supply of linear function. And if you remember, this is our equation where we have A minus, is it B? Yes. And we have Q equals to C minus plus D dP. And when we say this is the supply, and here we have demand. So if you remember, this is our linear function for demand and supply. So I was just reminding you, we are still going to use the very same equations, but right now the difference between the two, we are saying we want to find equilibrium. And for us to find the equilibrium, it means we need now to equate the given equation. So in this case, we're given an equation of demand and you're given the equation of supply, which is Q equals to 210 minus 3.5 Q. Oh, this is price. Sorry about that. This is price. Then we have the second equation that is given to us, which is Q equals to negative 90 plus 4P. So meaning for us to come up with what is called our equilibrium, then we'll have to equate the two given equation. If you remember, we said Q D equals to we said Q D equals to QS. So for us to calculate that, we're saying QD is equals to QS. From the given information, this is QD, and it also have subscript T here that represent price. In this case, we do the same. We have QD also that goes with, rather, this is supply again. So in this case, we have to equate these two equations for us to get our value. So we say, okay, if we are saying QD is equals to 210 minus 3.5 P subscript D, so it means in our equation, this condition, it means where we see Q subscript D, it means we'll substitute that by 210 minus 3.5 P. Same goes in Q subscript S equals to minus 90 plus 4 PS. It means if we are saying these are equal, where we see Q in this equation, we'll have to now substitute it with the right-hand side of our supply linear equation. So now I'll just repeat the equation. This is our equation.
Sorry, Mr. Klaba, while you're writing there, can you just repeat that? So where we're saying the 210 minus 3.5 PD, you mentioning that we substitute. So are we moving something to the other side? Please just
Come again. Can you repeat that? Can you repeat your question?
So you mentioned, you see where you underlined the 210 minus 3.5 PD.
Yes.
And the other side minus 90 plus 4 PS.
Okay.
You made a statement just after that to say where we see the P or the Q, we substitute.
This is S.
Mm-hmm.
So we are saying this is Q subscript S. So if you look at this equation, let's go the first, what is happening? Okay, I will use this. This is the same. If you look at this condition where we are saying Q subscript D equals to Q subscript S, this represents this part of the equation, Q subscript D. In the case of Q subscript S, it means this is the equation that will substitute this part of Q subscript S, because mathematically we are saying QS is equals to minus 90 plus 4P. So it means in this equation, where we see Q subscript S, it means we can put this because we are saying they're equal.
Okay, noted.
So,
Thank you.
okay, so in that case, it means now we are saying 210 minus 3.5 P equals to, remember this part, the left-hand side represent Q subscript D. So the right side of our equation here will be represented by my negative 90 plus 4P subscript S. Here we have D. So this side represents the quantity side of demand. This is the quantities of supply from the given equation. Are we together?
Together, yes, thank you.
Okay, what do we do now? Like I said, we are equating. So when we're equating, it means we are going to group the like terms from this given information. So to group the like terms, it means we are going to take, if you look at 4P, this side, it's positive. So bringing it to the left-hand side, it becomes negative. Then you're going to have negative 4P minus 3.5P equals to, then we take a positive 210 to the right-hand side. There we go. So now we can do our calculations. So if you look at this, it becomes negative 7.5p equals to negative 300. But if you look at this, we can get rid of this negative. Sorry, why? This is 300. So remember, our interest is to get the value of P, which is our price. So we divide both sides by negative 7.5. Even this side, it's negative 7.5. So when we divide, we ended up having P this side. P equals to 40. So the price is 40. So we got our price. But remember, we have the function of demand and supply, whereby our first function is QD equals to 210 minus 3.5 P subscript D. And we still have another equation of supply there, which is QS equals to negative 90 plus 4P subscript S. So we are saying, for us to say this is correct and it's balanced, this value, the price value, when we substitute it from these two equations, they must give us the same value. Then we'll be having an equilibrium. So for us to do that, it means you're going to take this 40. Let's look at the first equation of demand. Demand function. If you look at the demand function, we are saying, okay, we have Q, so now we have the price. We know what is the exact value of the price. It's 40. So we say, okay, Q D equals to 210 minus 3.5. Open brackets. Now, instead of now writing P, we know the exact value of P. It's 40, maybe 40 rand. So what do? We multiply. When we multiply and we look at the difference after multiplying, we ended up having 70 units. So we do the same, taking the same price. Now we look at the equation, the the supply function. We say, okay, Q subscript S equals 2 minus 90 plus 4 times, times 40 times 40. Then we multiply there. We do the same. After multiplying the difference there, it becomes 70. So you can see using the same price in these two different equation, the demand function, the demand linear function, and also the supply linear function, we have 70, 70. So from here, what do we do? Because now we have our value. Now we want to see our intercept now from the Cartesian plane. So we have to graph, we have to do our graph. So to do our graph, we say, okay, what do we have? We know that the coordinates of our point that form our equilibrium there, it's 40, which is representing the price, and it's 70 that represent our quantity. So if we go back, let's see what do we have. We have there, let's look at the first equation of demand there. We have, okay, I'll just erase it when we are done. So we can have our values that represent our variable, which is Q and P. So if we look at this equation, remember, this is our demand, which it has a negative slope. If we say, let's set, we set P equals to 0. We know when we set P equals to 0, this part will fall off, meaning we end up having Q equals to 110. Why are we saying this fall off? It means when we see P in this equation, we put 0. Remember, the reason we are doing this, we want to come up with a graph where we have the line that represent the linear function, the demand linear function, and the graph that represent the supply function. So we know that our Q in this case, mind, remember, it's not according to scale. So we know Q is equals to 110. So we say again, this case, let's say now we set Q equals to 0. And when we set Q equals to 0, what is going to happen is that we ended up having 0 equals to 210 minus 3.5p. If you take 3.5p, we ended up having that 10, then we divide by 3.5, and also this side, it's 3.5. This cancels that. Remember, we want P. P equals to, we say that, divide by 3.5, then we have 60. So we know that this side we have 60. Let's put our 60 maybe somewhere here, if you don't mind. So now we have two values that will represent Q and P from the demand function. So we'll have to have this, we'll have to do this calculation now to find two values that will represent the supply function. So it means this is going to be our line between the 2 point. Remember, this represent our demand. So we'll have to have the same equation. Now we are going to take the second equation, where the second equation we are saying it's Q equals to negative 90 plus 4P. Then again, we do the same thing. If we're interested to find the value of Q, it means we are going to say, in this case, let's set P equals to 0. So if we set P equals to 0, our Q in that case, it becomes 90. I hope you still remember that. And if Q is 90, remember going down our vertical, we still have Q, still represent Q, but this time it's representing Q on the negative values. I will just extend this just to make it more vertical. Then we can say here we have negative 90 that represent our Q. So we say again, now our interest is to find the value of, using the same equation, our interest is to find the value of P. If we want the value of P, we set Q equals to 0. Set Q equals to 0. And when we set Q equals to 0, we ended up having 0 equals to negative 90 plus 4P. Then maybe we can take this on the right-hand side. We ended up having negative 4P equals to negative 90. But remember, we don't want 4. Then it means we'll have to get rid, negative 4. We'll have to get rid of negative 4 just to have the value of P divided by 4. Then when we do that, we ended up having P equals to, there we divide 90 by 4. In that case, we ended up having 22.5. That represent our price. So maybe 22.5 at somewhere here. Okay. So what do we do now? We'll have to have a line that passes here, joining the other side. Remember, mine is not according to the scale. So we are saying in this first quadrant, where these two equations that represented by these two lines intersect, it means they intersect here. So at that point where they intersect, that's where we call it equilibrium. So that equilibrium point, remember, it's made up of OT that represent price and the quantity of 70. That's our market equilibrium. Questions?
All good.
All good. If we all good, let's continue. Let's move to we spoke about market equilibrium and we spoke about, now we are moving to labor market. Still also the labor market, it's not that much difference as compared to what we have done. Maybe the symbols are different, but the concepts and the application and everything still the same. Where they say labor market occurs when the labor that firms demand which is represented by L subscript D, is equals to the labor that workers supply, which is the same concept if you remember when we were talking about equilibrium of market, yeah, good market. If you look at this, it's still the same because we are saying when we're talking about market, we're talking about demand for and supply for the product. It must be balanced. Also, this side is still the same. We're talking about the balance between the the labor firm demand, which you are saying is equals to the labor work supply. The idea is still the same. We're talking about the balance between the two. And also this side, we're still talking about the balance between the two. That time, this side we spoke about uh, between supply, demand and supply of service or goods, and also this side. And we spoke about the prices, the balance between the prices, looking at the consumer, which is willing to pay, and what the producer is willing to accept from the consumer. Also, this side is still the same. This side, we're talking about the work, the labor demanding, and the labor work supply, where it must be balanced. We talk about the salary, where in this case, we can say maybe the salary, it appears the same as the price, whereby the price, and when we spoke about the price, where we said the price that consumer is willing to pay for your goods is equals to the price that the producer is willing to accept. This time around, we are talking about the wages or the salary that the firm is willing to pay to an employee, to an employer, to an employee, yes, which is must be equals to the wages that the worker are willing to accept from the employer. So the idea is still the same. We still have the same conditions where we say labor subscript D, which is L stands for labor, where W stands for workers. So we are saying L subscript D is equals to L subscript S, and we have W subscript D, which equals to W subscript S. And like I said, if you look at the equations are still the same, they're still appearing the same as where we started, when we started the first unit where we were discussing demand and supply functions. We are still going to have the similar functions and do the same functions. The idea is still the same, just that we are applying it in a different environment, but we are still following the same concept. I will take an example just to show how are we applying this when it comes to the equilibrium in the labor market. But like I said, it's still the same thing as when we are calculating the demand and supply. One, we still have to find what is the value of supply given the equation. For an example, if you remember our equation of demand or the function of demand, we are still here. The idea is still the same, but the interpretation is different. Just we are taking these concepts of demand and supply and applying in a different environment, whereby now we're interested to know what is the equilibrium of labor market. The idea is still the same, just that interest is to know what is the equilibrium of labor market. Where, for an example, we have L equals to LS. This side, we can say again, we have W D equals to WS. So the idea is still the same. We want the equilibrium. We want the two values. Equilibrium, it will be that intersect where the supply function There will be a line from the Cartesian plane that will be representing the supply function, the demand rather, the demand function, and we'll have another line that will be representing our supply, function from that equation, from that graph. So what we're going to do, maybe before we do the equating, let's get the values that exactly represent this equation and the supply equation. We are saying the given is L equals to 15 minus 1.67 WD. And if you look at this, we can say in this equation, this will act as our Q, and this will act as our price, just to remind you. But it's still the same thing. But in this case now, we want to know the labor and the worker. So what do we do now? For us to come up with our graph, now we'll have to know what is the value of L, the specific value of L, which is labor, and what is the specific value of W in this case, which is worker. So what do? We say, okay, still we said the interest now is to find the value of L. So it means if we want the value of L, we'll have to set W subscript D equals to 0. And when we do that, it means in this equation, where we see W subscript G, we put 0. So we have L subscript Q there equals to 15 minus 1.67, open brackets, 0. So this 0 represent W subscript D. So when you multiply here, this falls off. We ended up having Q, rather L subscript Q equals to 15. So we do the same. We know now we have 15. Maybe I should do this. That's 15. So now we calculate W. So for us to calculate W, to know what is the exact value of W, that will represent W in the Cartesian plane. We say, okay, let's set again now L subscript Q equals to 0 from the given equation. Then we ended up having 0 equals to 15 minus 1.67 W subscript D. So we take a negative 1.67 to the left-hand side. We ended up having 1.67 equals 1.67 W subscript D equals to 50. But remember, our interest is to have the value of W subscript D. So in this case, we'll have to get rid of 1.67 by dividing both sides using the same value, 1.67. Then we have W there, subscript D equals to, then we say 15 divided by 1.67. We ended up having maybe 8.9. Let's say 8.92. 8.92. So we know that our W subscript D there is equals to 8.92. So we are done with that. So we are moving. We do the second one using the second equation. And we're saying the second equation in this case is LS equals to subscript L equals to minus 5 plus 2.5 W subscript S. So we do the same. We want to have the values like this, 15 and 8.92. Then we set W is equals to 0. So when we do that, we ended up having L subscript S equals to -5. Then we say, okay, this time around, we are setting L subscript S equals to 0. When we do that, we ended up having 0 equals to -5 plus 2.5 W subscript S. And when we take it to the left-hand side, we have -2.5 W subscript S equals to -5. So we want to get rid of that, -2.5. So we divide both sides. So we have W equals to there, 5 divided by 2.5. We have 2. So we have 2. So if we have to do our graph, we know that we got -5, we have 2. So this is the line of supply. That is from the function of supply. So we have to do the second one, the line of demand. Now we have 15 there and we have 8.92. Let's put 15 somewhere here. Let's put 8.92 maybe here. Okay. So these two lines, they intersect here. So for now, this intersect, it is unknown. So for us to find this intersect, what do we do now? We have to use two equations that intersect here at this point. This point, we call it E. We know that E stands for equilibrium. So to have the value of here, or the two values that represent this unknown point, what do we do now? We'll have to equate the two equations that intersect at this point, which is point E. So we are saying the equations that intersect there, it's 15 minus 1.67 W D equals to minus 5 plus 2.5 WS. Okay. So now we managed to equate the two equations that intersect here at E. So what do we do now? Our interest is to simplify this so we can have a value that represents W. So what do we do now? We'll have to take the common factor and group them together. So we are saying, okay, let's take 2.5 W subscript S to the left-hand side, and we take this 15 to the right-hand side. So we ended up having negative 2.5 W minus 1.67 W D that equals to -5 minus 15. So what do we do now? We have to sum the like terms. 2.5 there plus 1.67. That gives us 4.71 W equals to that side we have 20, negative 20. And also the side we have negative 4.17 W. So what do? We want W. So we have to divide both sides by negative 4.17. There it goes. We ended up having W. So now we say 20 or negative 20 divided by negative 4.17. So we have 4.7. So our W there is 4.7. So now we want to get the value that represent L, which is labor. So what do we do now? We say you can take any equation, but remember, like I said, when we're doing for market, we said that these two equations, when we subtract the value of price, it has to give us the same quantity units. So also here we are expecting the same thing because now we are saying they are balanced. So it means when they are balanced, if you take this value and you subtract it from the first equation, it has to give you the same value that you're going to get when you substitute it from the second equation. But we'll do that in both equations. So we say 15 minus 1.67. This is our equation. So in this equation, where we see W now, we put 4.7. Then we simplify what we have. 15 minus 1.67. We have 7.8, let's say 5. So we have 7.115 as equals to L subscript D. So let's take the second equation and see, are we getting the same values? The second equation is negative 5 plus 2.5. Second equation is L subscript S equals to negative 5 plus 2.5 WS. Let me confirm it. Yes, this is correct. So we take the same value, this one. Then where we see W, we subtract 4.7. Okay, let's simplify it. Then we say 2 there, 2.5. 2.5 times 4.7. Then we have 11.75. Then we say minus or plus, yeah, minus 5. Let's go back. We are getting a different number. I'm trying to check what went wrong. 2.7. Let's check how did we do our roundup. I'm looking at this part just to confirm the value 4.7. We said 20 divided by 4.7. 20 divided by 4.17. Oh, I missed that 9. If you are having your calculator there, you'd see that when you divide 20 divided by 4.17, it gives you 4.796. So when they round it to 2 decimal, so you can see after 9 there, you have 6. So 6 is up, so it becomes 10, 10, it becomes 8. That is why they're having 4.8. Do you see that, guys? Hello?
Yes.
Yes. So it means here it was supposed to be, I missed that 9. It was supposed to be
Yes.
4.8.
4.8.
Yes. Why is 4.8? If you look at it, it's 4.796. So it means we have to be careful in terms of rounding. Then, but during the exam, we'll give you a clear indication how many numbers are we rounding to after comma. So in this case is 1. So if we're saying is 1, this is, if you look at this, this is 7. So if it's 1, because of now, it's about 5. It's about 5. 5 going up, we round it up. So it means this, you take it as if you add 1 here, you end up having 4.8. Okay, so we have 4.8. It means here we're supposed to use 4.8. And when you use 4.8, that becomes 1.67 times 4.8. Then what do we have there? We have 8. And the difference between 15 and 8 there, it will be 7. So it means now we go again to the second equation. It means also we have to correct that. Here is 4.8, which is 2 times 4.8. Then we have 12 in that case. We have 12. So the difference is the same. We have 7. So now what do? We have to do to give our unknown intercept now the numbers, because now we know that our W in that case, that's 4.8, and our L is at 7. So that's the correct values. So questions? Questions?
No.
No questions.
No questions
Okay.
yet, sir.
So if we don't have questions, let's move to okay. We're discussing the equilibrium in the labor market. So we are moving. We have price control and government intervention in the market. And we are saying price control is from government, where the government imposed to ensure that the goods and services are affordable. So when they mean the goods and services are affordable, they're looking both sides. They're looking at the consumer side, and also they're looking at the producer side. That government, it protects them both in terms of buying and selling our goods and services. So we are saying in a case where the government is protecting the consumer, that we call it price ceilings. That's where the purpose of government is protecting the consumer, that they don't pay excessive high price of goods or services. Also, in a case where we have what is called price floor, is whereby now the government, the interest of government now is in the producer, where they're saying, okay, they look at that the producer is not selling with a low price. So the government is helping there. The purpose is to protect the producer for charging lower price. So they don't want the consumer to pay a maximum price, and they don't want producers to sell with the lower price. So that's what is called price control. Then we look at how do we calculate the price ceiling, where now the interest of the government is to see that the consumer, they don't pay high price when it comes to goods or services. So we'll take an example looking at the first one, which is the price ceiling, which is somehow similar to what we've been doing, whereby we'll be given also the two equations that represent the side of demand and the side of supply. So it means we'll be given the demand function and also the supply function, so we can be able to calculate the price and be able to know what is the selling price. If we are introduced to the selling price, what are going to be the changes in terms of now, what is the price the consumer must pay? So let's take an example. So the idea is still the same, where we're given two functions, like I said, which is the demand and the supply function. But the interest now is to compute the price ceiling. If you look at this is still demand function. But if you remember the original equation of demand function, we are saying Q is equals to A minus B P. These are still the same. But now if you look at this one, it means there's a transformation that needs to be done here. This is the original equation. So we have to transform this so now it can appear as the standard form of the demand function. So what we're going to do there, it means we'll have to divide throughout by negative 0.5. So we can have our standard function of our standard equation of demand function. So if we divide throughout here, you see that you ended up having, if we divide by 5, remember there's still 1 here, even if it's not there, still 1. So it means we have to divide by 0.5. We divide by 0.5. Also, we divide by 0.5. And when we divide, we ended up having we have Q equals to, if you divide here, you ended up having 200. If you look at this one, Q, it was negative when it was on the right-hand side. So after dividing it, we moved it to the left-hand side. That is why you see now as positive, because it was negative on the right-hand side. So moving it to the left-hand side, it becomes negative. If you look at P, your P, it was positive on the left-hand side. But now moving it to the right-hand side, it becomes negative. But don't forget that we divided. We said, like I said, there's 1 here. And remember, 1 times P is still P, doesn't change. But when you divide here, we ended up having negative. It becomes negative because now it moving to the right-hand side. That is why it becomes negative. Then we have negative 2P. So, and when you look at this, it's the same as the standard or the linear function, the demand linear function equation. This is the linear function equation. Now you can see after transformation, these two, they look similar. You have your Q there, you have your A, which is your slope, which is now, your intercept, which is 200, and you have your negative slope there, which is the same as this one, which is -2. So we are fine. We got our equation, which is our demand function equation. So we move on. The second one is P subscript S there equals to 10 plus 0.5 Q subscript S, which is the same. It's not in our normal standard form that we know, where we say Q is equals to C plus D times Q. So now we'll have to change it, transform it again, so it can look like this. So what do? We do the same like we did here. We'll have to divide throughout by, sorry, we have to divide throughout by 0.5, because our interest is to get rid of that number. So what do we do now? We divide by 0.5. We divide by 0.5. When we divide, we ended up having Q there equals to, then we say 10 divided by 0.5. We have 20. Then we have our P there. We have our P, then it becomes negative. Let's see. We have 2P there. Where's P? Here's P is positive. When we divide, it comes to the left-hand side. To the right-hand side, it becomes 2P. There's something that doesn't make sense. Because if you remember, our slope is supposed to be negative. I'm trying to check what went wrong. Okay. I think what happened here, they took this 10 because of now we know that our slope, not our slope, our intercept supposed to be negative. So what happened here, they took 10 to the right-hand side, to the left-hand side, sorry. Let me rewrite it. If you look at the equation, we have P subscript S equals to 10 plus 0.5 Q. So what they did here, now they took 10 before they divide to the right hand, to the left hand side. So if you do that, you ended up having P, we can say PS minus 10 equals to 0.5 Q. So you divide, when you divide, you ended up having 2P subscript S minus 20 equals to QS. Then we can rewrite it in a standard form way. And if we rewrite it in the standard form, remember our standard form, we are saying we have Q equals to C minus C plus D times Q. So that is QS equals to negative 20 plus 2 P subscript D. So this is our equation. Our equation is Q equals to negative 20 plus 2 times P subscript S. This side, our equation, we have QD equals to 200 minus 2 times P squared. Not squared, Q down there. Why QD? Yes. So now we have our two equations. So we know that this is our two equations. So now we want to calculate to find the equilibrium price and the price and the quantity from these two given equations. So what do we do now? We say Q we have QD equals to QS, and we also have PD equals to PS. So now we want to find the equilibrium points of these two. So we say 20 minus 2P equals to negative, rather 200, sorry, it's 200 plus 2P. So we grouped the like terms. When we group the like terms, we can say we have negative 2P minus 2P again equals to, this side we have negative 20, negative 200. Then we end up having negative 4P there equals to negative 220. We divide by negative 4, also by negative 4. Then that falls off. We ended up having 220 divided by 4. Then we have P equals to 55. We have 55 there. No, I made a mistake, which is Q. It's not P. Q is the dependent. Okay. Yes. Okay. Just a minute. I want to confirm something here. QP. Yes. Okay. Okay. Sorry about it. I think, okay, the problem is somewhere here. The idea is correct. I think the only thing that was wrong is the symbol that I used. We're not supposed to transform the equations. We're supposed to use them the way they are. So in this case, we have P equals to D 100 minus 0.5 QD. And the second equation there is P is equals to 10 plus 0.5 QS. Yes, we are not supposed to transform it. So we still do, whereby now we equate P subscript D equals to P subscript S, where we have, if we simplify it there before we equate it, still the same, where we are going to have Q equals to 200 minus 2 PD. And the second one, which is this one, we have Q there for S, this is D, equals to negative 20, like I did, PS. So what do we do now? We equate where now we want the price. So for us to have the price, we say 200 minus 2 P D equals to negative 200 plus 2 P S. And I think I've done it. D equals to, then we have negative 200, then we divide. Let me cancel that. Oh, I just need to check something. Something doesn't make sense here. Q. Guys, there's something that I don't know unless I'm missing something here. Are we still together?
Yes. But
I don't know if I'm missing something.
No, actually, I have a question, Mr. Baba.
Okay.
I'm a bit confused right now. I was with
Okay.
you for a minute, then I just got confused. If it's possible, can you please go up? There was an equation that you were calculating where we divided 100 by 0.5,
5. Okay.
and then I did see that the answer was 200 rand, but I'm lost with the minus 2p and plus 2p. Where is the 2 coming from?
Let me do this. This is where we started. Okay. What was your question? Because now I'm starting this is where we started with the two equations, where the first equation is
Yes,
equals to
that one.
200.
Yes, yes.
It's 200 minus 2p. Hello?
Sorry, if I may interject, please. So she's asking where is the 2p from? It is from when you divide the p, the p is actually 1p, just that we do not
Yes.
write 1. But then when you divide 1 by 0.5, you get 2. That's where you'll have 2p. Is that okay?
Yes, this is where I explained. If you remember here, I said we have 1 here, and I said 1 times p is equals to p. So when you divide, it's the same as you say 1 divided by 0.5. That is why we ended up having 2p.
Okay.
Are we together?
Yes, yes. Thank you.
That's how we got this 2p. Okay. But now
Thank you.
there's something that is a bit confusing me here. We got the value, but now looking at how they've done the calculation, it looks like, because now if we equate this two, it gives us a price.
I am okay. I'm not sure if I can also come through on this one. I'm
Okay.
looking at the example. I think the first one, the first attempt that you rubbed off and said we should not transform. I think it is to be transformed to to equate to be equated to Q, the quantity demanded.
Yes, I
And
agree, but we get the same value. We get the same value, which is 55. But now it appears as a 55, it's quantity. But looking at the equation, our equation, we're saying it's QD equals to
oh,
QS.
now I see. Okay, I see.
So I don't know, is something that I'm missing or is the study? I'm not sure of that. Because now if we have this, okay. Because, okay, for interest sake, let's take this. If we are saying this is a price, then I'll have to look at it again. If we are saying this is a price, we take one of the equations that we have here. Let's take this equation. Where is our equation? Where are our equations? Okay, we have equation of Q equals 200 minus 2p. And we are saying Q there is equals to 200 minus 2 times 55. I just want to check something. Then we have 55 is 110 there. And if it's 110, it means our quantity becomes 90. And we take the second equation. The second equation, we have negative 20 plus 2 times p. Then we are saying in that case, we have negative 20 plus 2 times 55. In that case, we still have 90. But now the challenge that I'm having, I don't know you see that. We have 90. In the study guide, it appears as 55 as a quantity, is not a price. Do you see that?
Yes, we do. I think it could have been a mistake because throughout the calculations, of course, it looks like it's swapped. The price is 90, but we get that the quantity is the one that is 90.
Yeah, that is why I'm a bit confused also, because now I was just taking numbers doing the calculation. Unless if we try to see, if we equate the price now, we say the price D is equals to the price subscript S. And we
Sorry,
go
sir.
back to, okay,
Sorry, sir. I just
Yes,
want to
I'm
ask something
listening.
quickly. The quantity here, well, I'm looking at the example in the study guide. It says the
Yes.
quantity is equal to 55. The quantity at equilibrium is equal to 55.
Yes.
Yes. So now, I'm not too sure where you're getting confused, because if QD is equals to QS, it should give us 55, which it did.
Remember, if we equate, remember we transformed. Immediately when we
Yes, we
transformed,
did.
if you look at the original equation, it's P subscript D
Yes,
equals to 100 minus 0.5. And if we equate, it means that
100%.
0.5, let me finish quickly, then I'll give you a
Mhm.
chance. If you look at that negative 0.5, it's a coefficient of Q, and we don't want a coefficient of Q.
Okay.
You see that? And once we get
Yep.
rid of that 0.5 and we take it to the left-hand side, it becomes positive Q. Then we have that 200, that where we say 100 divided by 0.5. You see that?
Okay.
Yes, that is why we ended up having that equation that after the transformation, after we transform, that is why we're having Q equals to 200 minus 2PQ. But what I'm suggesting, maybe instead of now using equating Q, D equals to QS, let's look at the price where we have PD minus PC. Do you see that? So it means we don't transform what we have, we take it the way it is. Do you follow?
Yeah.
What I'm saying now, we have the original equations where we have P subscript D, 100 minus 0.5 Q. You see that? So now we don't transform, we don't do anything. We just take the equations the way they are.
Okay.
From the given example. So if we take them the way they are, it means now we'll be equating P subscript D equals to P subscript S. It's no longer Q subscript D equals to Q subscript S. So it means now we take the equations the way they are. So if we say P subscript D equals to P subscript S, the equation that will represent P subscript D there, it will be 100 minus 0.5 QD equals to, in case of P subscript S, it means we'll be having 10 plus 0.5 Q subscript S. Do you follow?
Okay.
Okay, so now we try to simplify this now. When you simplify that, it means we're going to follow the same procedure. Now we take this one, we bring it to the left-hand side. Then we have negative 0.5 Q minus negative 0.5 Q. Again, equals to 100, let's say yes, 100 minus 10. But it means, no, I think there's something wrong about it. Because now if you look at this, we are saying we ended up having Q this side. Then we have Q. We have Q. We have negative Q equals to 90, negative 90. Do you see that? Then we get rid of negative. And when you get rid of negative, we end up having Q equals to 90. Do you see that?
Yes.
Guys,
Yes, we see it.
our Q is 90. And if our Q is 90, it means it takes us back. It takes us back to our first calculations. Remember, this is our first calculations.
Mm-hmm.
And if you look at our first calculation, Q is still 90.
Yep.
So it means there's something wrong about the study guide. Because now, even if you equate P, D, and PS, it still give you
90.
90. And 90, that 90, it appears as Q. And the price is still 55. So it looks like that P that appears as 90 is supposed to be 55. That Q that appears as 55 is supposed to be 90. I don't know. You follow me? Do you follow me, guys?
We do. We do follow. I think I do from my end because my little understanding is even if we use PD equals to PS or either QD equals to QS, we're supposed to land on the same solution, on the same answer.
Yes, yes. And that's what we got. So it looks like from the study guide means they made a mistake. There was a typing error.
True.
Okay. So it means in that case, we know the price is 55. And if the price is 55, the quantity is 90. So that's where we are. So we continue and it says, suppose the price ceiling of 40 Rand is introduced, where the initial price that we're having now is 55. So now the price that is introduced is 40 Rand. So meaning what we're going to do, we look at from the two equations. The first one is this one, where we have P here. If you remember, this was P. And the second equation here is, let me rewrite them. So if I rewrite them, okay, we have Q D equals to 200 minus 2P. And now they're saying, okay, now we're introducing a new price of 40 Rand, where our price, it was the calculated price, remember, is it's 55. Here it is. So if we introduce a new price, then we have 200 minus 2 times 40. Then we subtract there, we have 120. Then we do the same with the second equation, where we have Q as equals to negative 20 plus 2 times 40. Then we have 60. So we know that it means demand is higher than the supply at this price, and a shortage is 20, this 120 from the unit, the first unit and the second unit of 60. So the difference there is 60 units that exist in the market. So is when the new price ceiling is introduced. So they are saying now we have to compute our profit. What do I do now? Oh, before I continue, any question?
No.
No question. Okay. Mhm. Trying to create a space. In a new page. Okay. So now our interest is to calculate the profit given the information. And we know that the profit is equals to T TR minus TC. And we are saying we have number of sold, which is demand, times, I'll just say full stop for times, price per unit, minus number what times the cost per unit. So it means we are going to use the information that we have. And when you look at all the calculations that we have, we are saying number of sold, demand, we have 60, open brackets, then times the price per unit, which is we calculated, which is 70, minus number brought, which is up there, 60, open brackets, cost per unit, it's 40. Then we simplify it. We say 60 times 70. Minus 60 times 40. Then we want the difference. That is our profit. Questions? Before we go to price ceiling, or we can continue to price ceiling when we meet, because we went, or we can continue. If you allow me to continue, I can do that. Should I continue?
Yes, please.
Okay. If you look at the price ceiling, it's still the same as what we have done under the, now we are moving to floor from ceiling. We're moving to floor. So what do we do when you move into floor? Remember, the interest now is about the producer. So we are saying, when it comes to calculating, we have given two labor market with demand, and we have supply function, where we say, given we have D, rather WD equals to 9 minus 0.6 L subscript D, and the second equation there is W subscript S equals to 2 plus 0.4 L subscript S. So we do the same. We can divide. When we divide to get rid of this, so we can have our L, our LD, or let me say our Q equals to, because now we're talking about the demand, first one. Then we can have A minus B. We are doing the same thing. So also this side for demand, this is demand. And you also have supply here. So we'll have to do the transformation. So when we transform, we ended up having L subscript D there equals to. So what do we do now? We have to divide that 9. We divide 9 by 0.6, then we have 15. 15, this is positive. Then when it moves to the right, the right hand side, it becomes negative. But now it's going to be 1 divided by 0.6. Okay, then we know that we have negative 1.67 WD. This is after transformation. Then we took the second equation. The second equation, you can see we have W equals to 2 plus 0.4 L. Then we have S there, LS equals to, we divide both sides by 0.4. When we divide by 0.4, we end up having negative 5 plus 2.5 W. Yes. So our interest is to do our graph. So what we are going to do now is to equate the two. We have to equate the two. Okay, let's look at our graph. Okay. Let me go back to our equations. Okay, these are our two equations. And the question says, if the government make a law that the wages must not be lower than 6 rand per hour, which is higher than the market equilibrium, employer will have to employ fewer people, increasing employee demand too. So for us to know that, since well we are given 6 rand per hour, that represent wages. So it means where we see W in this equation now, we have to substitute that. We'll take the first equation. Then we calculate that 15 minus 1.67, open brackets, so we have 4.98, which is somehow equivalent 4.98 equivalent to 5. Then we look at the second equation, we do a similar thing like we did when we're doing the price ceiling. Then we have LS equals to negative 5 plus 2.5, open brackets, still using 6, which is, then we say negative 5 plus 2.5, open brackets, we have 6, Then we have 10 laborers. We have 10 laborers. So now, after doing this calculation, what is expected from us is to come up with our Cartesian plane. So let's do our Cartesian plane. Let's take the first equation. We say we have LT equals L 15 minus 1.67 WD. Then we set W equals to 0. Then we ended up having D subscript L subscript T equals to 15 minus 1.67 times 0. Then we have 15. We have 15. Then we say, okay, now in the case whereby now we want W, we say, okay, let's set L subscript T equals to 0. So now we have 0 equals to 15 minus 1.67 W. So we take that, we end up having 1.67 W T equals to 15. Then we divide both sides by 1.67. This side we have 1.67. Then when we divide there, 15 divided by 1.67, we ended up having W is 8.982. We can say is equivalent to 9. So we know that we have W D equals to 9, and we have LD subscript D equals to 15. Then we take the second equation, we do the same, because the point is to find the value that will represent the two equations in the Cartesian plane, where we have L subscript S equals to -5 plus 2.5 WS. Then if we set W equals to 0, we end up having S equals to -5 plus 2 times 5, 0. Then L in this case is equals to -5. Then we do the same. Now we set L subscript S equals to 0. When we do that, we ended up having -2.5 W is equals to -5. Then we divide by -2.5 and -2.5 both sides. So when you do that, we ended up having, in that case, we have W equals to 2. So we have W equals to 2, and we have L equals to negative 5. So according to our Cartesian plane, we have L this side, we have W. So in this case, we would say, what is the maximum between the values of W? Okay, we have 9 here, which is the maximum. Then we can just put 2 here. Then we have 15 this side. And this side, we have negative 5 somewhere this side. Let's put it here. Negative 5, that's fine. So what do we do now? We have to draw our graph. So our graph, it looks like this. That is our graph. And also, if you look at this one, it's going to move from this side, and it goes this way. Okay. So now our interest is the floor price that is given to us at somewhere here, which is 6. If you remember, we use 6 then to calculate. Then, based on the given price, this is how the graph is going to look. So it means from the values that we calculated, if you remember, when we are calculating from the given equation where we substitute the given floor price of 6, from our equation, we got these values. We got 5 and we got 10. So it means we'll say we have 10 here and we have, let's say, 5 here. These are the values that we calculated, L values that we calculated where we substituted a value of 6. So, and it's not according to Cartesian plane. I'll just move it. Oh God. Okay. Rather, this is 5. This is the calculated 10. So that's our Cartesian plane, whereby now we have the ceiling price of 6. Then we are done. Questions? Questions?
No question from my end. Thank you.
Okay, if we don't have questions, okay, we can close our session. Okay, we can close our session.
Sorry, sir. Can I ask you a question quickly? Hello?
Hello?
Hello, sir. Can
I'm
you hear
listening.
me?
Yes, yes, I do.
Yeah. Where can I find the previous recordings? If at all there were previous recordings for the other lessons. I mean,
I will check with the primary lecturer where the previous recordings.
all right. And will you communicate in the group chat or in the channel itself on Microsoft Teams, or you email,
I
or
will
should I email
communicate
you?
it in the I'll communicate it in the chat. I will ask her where the documents. Maybe I can just share them here or via the module
All
site.
right. All right. Thank you so much.
Okay, if we don't have questions, we can close the session. Bye.